please support me through PayPal to devinwyndham@gmail.com. I also do tutoring, both in person and online. I am based in Fairfax, Virginia. You can contact me for tutoring at this email. Please subscribe to my channel. Alright, in this video I want to give some mnemonics for the sum and difference identities of sine and cosine. Alright, so here are the identities, and now for the mnemonics. So, my mnemonic is, I think of sine as the good son and cosine as his bad brother. So let's say that sine, by the way, this idea of sine being the good son and cosine being the bad brother seems to pervade basically all of mathematics, not just these four identities. Anyway, suppose on his birthday sine gets two toys, A and B. Now, being the good son, he shares with his brother cosine. So during the first hour, sine plays with A and cosine plays with B. And then they get bored after the first hour, and so they switch. Cosine plays with A and sine plays with B. So that's along the first dimension, how sine being a good son pervades this first identity. The second dimension is that for the learner of math, he's not going to switch up the sign, no pun intended, on you. You have a plus sign on the left and a plus sign on the right. Now the second identity is basically the first, so the sharing of the toys just translates over. Also the signs, no pun intended, since sine is a nice guy, he's not going to switch it up on you. Right now for cosine, the bad son, he's a selfish hog, so on his birthday he gets two toys, A and B, but being the selfish hog that he is, he hogs up both toys during the first hour. Cosine plays with A and cosine plays with B during the first hour, and he's leaving sine in the cold. Then he gets bored after the first hour and says, okay, sine, now you can play with the toys. And being perverse, he also switches the sign, no pun intended, on the learner of math. So this plus becomes a negative. And again, the same mnemonics translate over. He's a hog, and also he switches the sign on you. Negative goes to positive. All right, now to show how this idea of sine being good and cosine being bad pervades all of math, first I guess I was wondering why. Like, let's consider the graph of sine. So let me draw my x-axis and my y-axis. And just consider the identity function, y equals x. Y equals x, let's label these. So y equals x is just a harmless function because it doesn't change x, and it's a 45-degree line, right? This is y equals x, plain vanilla. Now let's consider the graph of sine. It sort of looks like, this is my, this is just a rough sketch. I'm not sure how accurate it is, but sine is going to sort of look like that. I guess it looks something like this. Not sure how accurate that is, but notice it's sort of like that. It starts out at the origin like y equals x. Let's label this y equals sine x. So it starts out at the origin, and it goes up and to the right, sort of like normal, and then down and to the left, sort of like a normal function sort of would. Whereas cosine's odd. Like cosine doesn't start at the origin, it starts here. Like that's where cosine is. Also, interestingly, y equals x is sort of a good approximation of y equals sine x near the origin, because we know that the limit as theta approaches 0 of sine theta over theta is 1. All right, so that maybe explains why throughout math we see this sine being good and cosine being bad thing. Let's look at their derivatives. For their derivatives, cosine is the one that changes the sign on you. So, we're changing the sign. So, for doing calculus, I have this mnemonic that if the father has a there's a sign change. Now in calculus, I think of like the original function, let's say sine right here, he's the father, and the derivative is the son. Like derived means, comes from. Like we could say that, cosine, we could say that fudge is a derivative of chocolate. So this is the father, that's the son. So my mnemonic, if the father has a there's a sign change. Let's see how this works. So here's the father, there's no there's no sign change. Here's the father, there's a CO, so there's a sign change. Let's do this antiderivative. So here's the father, the original. There is a CO, so we know that there's going to be a sign change. And this thing about if the father has a there's a sign change, I think it is also going to apply to cotangent of x, the cosecant of x, the arc cosine x, arc cotangent, and arc cosecant. And why does it apply to these arc ones? Well, again, if you understand, which I recommend that you understand math, you sort of can know or visualize that the derivative of an inverse function is 1 over the derivative of the plane or the parent function, and so that's why it would translate over. This thing about, again, cosine being bad, or if the father has a co, might apply to like the hyperbolics like sine and other stuff, or anything where this co might come in handy. Anyway, I want you to enjoy math and physics. One way to do that is notice I write on printer paper, because if you have lined paper, the lines might get in the way. I also use a pen because I find pencils to be scratchy and annoying and always getting dull. Again, my main thrust in my videos is that understanding is more important than memorizing. Here in this video, we've been sort of doing both. It's fine to memorize so long as you understand first. Unfortunately, these 4 identities are fundamental to math, but they're super hard to prove. So we didn't really prove them today. We did some mnemonics. I think mnemonics are good. They're useful. I didn't do the proofs of these because I don't know how to prove them. They're just, let's say, beyond me right now. I hope to do a video soon on proving these guys. Why don't you try to prove these guys? I proved them before, and it was like the hardest proofs I've ever done. But I forgot my proofs. These are mnemonics. They're not understanding, but we're sort of understanding because we're melding our mnemonics into like a system of overarching math, and we sort of explained why the mnemonic sort of works. Anyway, bye for now.